So we learned, we basically just gave you a whole bunch of concepts, like databases, how to interact with a database, writing REST APIs. This final section is about how you put it all together, right? We're going to teach you a concept called dependency injection. It's going to come up often in backend software engineering. It is a key concept for you guys to understand, right? Let me just, right. So there are three main aspects to a server that we will write, right? Here, this is the APIs. This is the REST APIs that Emre has talked about. This is responsible for communicating with any of our servers like consumers, right? The GET APIs, the posts, the puts, and the deletes, it gets all handled by this. And this is related to the HTTP, communications. Yeah, this is what it all cares about. The data layer, this is what is responsible for communicating with the database, right? All the SQL stuff that we learn, all of the database commands and all that kind of stuff, it should all belong to the data layer, except all the migrations, right? The migration stuff should be run once at the start of the server when the server is started for the first time. It is not part of the data layer. It's just part of a startup event, right? But anything related to creating, updating, deleting, and getting stuff from a database, it should be from here. The service layer is where all of the other business logic and all that kind of stuff happens, right? So the service layer, it will take a request from an API from the control layer. It will do some magic. It will do some business logic, and then it will save to a database, and then it will just return the response. Or it will get a request from the controller, like a GET request. Hey, get this for me. The service layer will ask the data layer, hey, can you get resource number 1 from the database for me? Then the service layer will just take it and then just return it to the control layer, and the control layer will respond with it, right? So this is the three big aspects of a server, right? And no matter which way you slice it, or just look at many different kind of software architecture, there will always be a part that is going to be responsible for communicating with the outside world. There will always be a part that is related to persisting the data into a database or some kind of storage. It could be a relational database, a document database, or any kind of database. There will always be some part that is responsible for that. And everything else is going to be here in the service layer, right? And the whole name service is a very abstract concept. So what you really need to understand is whatever is not communicating with the outside world, whatever is not persisting to a database, whatever that remains should ideally go here, right? And we can see that there is a clear separation of concerns. They're all they all have to do different they have different things they should be taking care of. And our code should reflect that. Otherwise, things get a bit difficult to do, right? So let's see. So what developers I just kind of like to do is they put the word service as a postfix. So this email service means that this email service, this class or this module or package, whatever, will send emails. This payment service will just handle payments, and this logging service will just handle logging. So it's also a term that we use, right? And dependency injection, right? So I think this is best demonstrated with code, right? Back to my testing example here, right? You can see this widget factory, right? This widget factory is depending on this API caller, right, to function. But we can see that the actual API caller, it is not instantiated inside the widget factory. There's nothing. Just ignore this for a moment. Ignore this, right? There's nothing that says that the API caller is just like created inside here, right? So when we actually create this instance of this class, right? Widget factory. You have this widget factory. Instead of having the API caller be directly created inside the class, we don't want to do that. What we want to do is inject it inside the factory upon its creation. So we have the API caller here, external API caller. We create the instance outside, and then we inject it into the API caller. This is all what dependency injection is. It is not a super crazy or I think like complicated concept. There is something that depends on something else, right? A depends on B. Instead of creating B directly inside A, we will create it outside and then put it inside A as we are creating A, right? That is all it is, right? Questions about this? Did what I say not make any sense?
It is not inheriting from a class, right?
It is not inheritance, yes. This is more composition. We compose different things together to build what we want. Yes, like Lego bricks, right? And dependency injection, it can be things other than classes, right? So like def produce widget, right? This API caller, abstract API caller, and let's just copy this here, and then just copy this here, here. So we can see here that for this like function here, that also depends on the API caller because it takes it as an argument, right? So what we can do here is produce widget. Produce widget. It will take the API caller as the API caller that we defined above here, and then the year as 2024, and country code as Korea, right? This is also dependency injection. You inject the dependency of this just through the arguments here. This is all that it is, right? It is not a supremely, I think, difficult concept as people may make it out to be. And now why do we care about that? We have other examples here, but I think it's best to show with the code that we have right now, right? In the app, we have the service here, right? We have this product service. It is responsible for creating, paginating, updating, getting, dealing, all that kind of stuff, right? But the main problem is that there's like there technically is dependency injection going on because we're injecting the database connection like dependency, but it is not ideal, right? Why is that not ideal? It is because of a reason called coupling, right? So coupling is the degree to which like software modules are dependent on each other or know about each other, right? This product service right now knows too much about SQL, right? If you go back to here, I told you that all these different like layers should only know about their own layer, right? So the service layer should not know about the data layer. It should not know about like SQL or anything, right? It should not know anything. And the controller should not know about how the service does its logic. It shouldn't know about SQL. It shouldn't know about everything. And like the opposite is true. The data should not care about the service, and the service should not care about the controller, right? So what we can do, right, is to make a data layer, right, and then inject it into the service so that the service has no idea about SQL or anything, right? So I'm gonna refactor this live and show you how it's done. So I have here this thing called a repository. A repository is a sort of a design pattern that is often used in backend programming, and this is basically the data layer that I've talked about here, right? It only really cares about inserting, updating, deleting, getting stuff and getting the count and pagination and all that kind of stuff. It does not know or care about any other like implementation detail about the business or any kind of like business rule or whatever. It only really knows about the database, and it's going to stay that way, right? And I've created an abstract class, and whatever inherits from this class has to implement all these methods, right? So I implemented this repository here, and then I implemented the insert statement, the update statement, the delete, getting one, and of course, pagination, right? And to get this to work, this will take the database connection instead, right? Before we were taking the database connection straight into the product service, but we're not going to do that anymore. This will know about the database connection. This will not, right? And this will need to know about the table as well, because we're going to be inserting into the product table. This will take the product table as the argument when we instantiate this class, right? So I'm going to first let's do repository, and it's going to be of type repository. And it's going to be, I'm just going to do it like this at the moment, SQL Alchemy repository. And the DB would be depends database connection. And then the table would be a product table. Right. This will inject the SQL Alchemy repository by default, although this is not great, but it just works, right? This will inject the SQL Alchemy repository upon the creation of this product service, right? Self dot repository will be repository, right? So I'm going to refactor this, right? If we look at the methods here, let me go to database here. Let me just put it to the side here. Close this. Cool. So all of this stuff about inserting, the service layer does not need to know anymore. So I am going to delete all of this. The results, hold on. Results is going to be await repository dot insert dot self dot repository dot insert hold on, product model, I think it was model dump, right? Model dump returns a
Dictionary.
Yeah, returns a dictionary. Okay, so what we see here compared to before, this part right now has been refactored to use the repository, and it now knows nothing about the database, but the function is the same, right? The insert statements, the executing the statements is all the same, right? So this I'm gonna repeat this for every single like method we have here. I'll do pagination last. For get detail, right? I'm going to remove all this. Result is going to be await repository self dot repository get one ID, right? It doesn't know about the database stuff. Nice and clean, right? Update. Result is self dot repository update. ID will be ID, and the data would be product dot model dump. Model dump, yes. Model dump. And then finally,
You need an await.
await, yes. I'm surprised nobody asked about async stuff.
Does
But
everyone know what async await is? Or better question, who does not know what async await is? Okay, so
let's explain
yeah,
that at the
we'll
end.
come back to it.
Yeah. Self.repository .delete ID. Yes. And as for the pagination, let me just remove all this. Results records. Self.repository. Let's do the await. Paginate. Select statement will be product table dot select. Hold on. What is the argument? What are the arguments? Filters, we have no filters now. We're just selecting everything. We have the ordering. There's no ordering right now. So offset would be list query. No, where is it? Why? Where are the fields? Let's see, base pagination. Every page, and then size would be list query plus size, right? This will do the results, and then for the count query, let me just change this real quick. Base list response, it's just going to be page int size int, and then it's going to be count int. Cancel. Page is going to be list query.page. Size, list query size, and then as for count, await self.repository.getCount. Select statement is going to be the same, product table.select, and then filters would be nothing, and then the count would be the count, right? So we refactored everything to use dependency injection, and then we are going to just remove this because we don't need to know about the database now from the service layer. Hold on, why is this redefinition repository from line 2? Hold on, no, we don't need this. We don't need this. We don't need to import anything about the database now. We only need to know about the repository, right? So we can see here a clear separation of concerns, and this makes this code much easier to test, right? So beforehand, before we did all this, there were so many methods related to databases. Let me just look at the difference here. Yeah. Before we did all this, right, we had to do, if we were to just mock or patch or stub out or fake any kind of like operation, we would have to fake the execute. We would have to fake the insert, the values, the returning, and all that kind of stuff first. But afterwards, the only thing we need to do is if you want to replace this dependency, right, of this database dependency, right, is to change this into something else, right? We can inject a fake repository, or we can just inject a mock, or we can just inject a stub, right? And this makes writing and just like maintaining the code like much more easier, right? So this is what dependency injection basically is, right? It separates out concerns, and then it injects it into whatever use case that we have it for, right? So any questions so far? Any questions?
Can it be other database?
Yeah, so this makes it easier to switch out databases or like ORMs, right? Right now we're using SQL Alchemy. If you want to use a different ORM like Turtle or like whatever, we can change the implementation detail inside here. But since this only really knows about inserts here, this will just work the exact same way. But if you want to change this into to use Mongo, this will also be easy because right now the service, it doesn't know about the database. So switching it is going to be easy to use like a document database if you want to. Any questions? Any questions about dependency injection? Because this basically is dependency injection. There's nothing really more I can show you, right?
So did we explain what the depends function does?
That's the fast API thing. Should we explain it now?
It's how fast API does dependency injection.
Okay, I'll explain how fast API does it. So how fast API does dependency injection is a bit different, right? So the first thing you need to understand, right, is that functions can be passed around as arguments, right? Right. So a function, according to type in Python, is of type callable because you can call the function, right? So what this function will do, function 2 will do, is it will take this as an argument, and then it will just call the function, because this is how you call a function in Python, right? If you wanted to call function 1, we would just take function 1 and then do this, right? So what we can do with stuff like this is, right, is if we want to call function 2 with function 1, we can just pass in function 1 without the brackets, right? Normally, if you want to just call function 1, we just do it like this. But if we just leave it like here, leave it like this, right? This means this won't get called, but it's still a function. So what you can do, right? So what this will essentially do, right? It will take which basically is function 1, right? It will just call function 1. Yeah, this is what will happen inside the code. And if you've observed how depends works, right? This database connection is a function, and we passed it inside this depends without actually calling it. We just passed in this, just like this. It's the exact same way, right? So what Fast API will do, right? What Fast API will do is, let's go to the controller layer, right? Let's go to the control layer where we inject this product service. Hold on. Oh, roots, yes. This product service, it depends on the product service. And you can see, you can notice here that if you want to create a new instance of a class, we usually do this, right? But we don't do that here. We just put in the product service here, right? So what Fast API will do, when it see that it has a depends, when it has like a callable inside the depends, when this endpoint gets called by the front end or by anyone, what gets done, which is hidden from you, is it will create, yes, what it will essentially do is it will create product, will be the product create with product create request. This will be from the client, which is like sending the request to us, right? But what product service it will do, it will just create this. And this is essentially what happens when a endpoint is called by Fast on a Fast API like server, right? It will just do this for you. Instead of you having to go product service equals like product service like this, right? Instead of you having to do it like this, right? If you put it inside the depends here, a callable, it will just do this for you. And this may not seem like much, but when the objects or the dependencies get more and more complex and have like a lot more dependencies, having all the dependencies just like properly injected into you by Fast API is going to be useful. And this is what like depends does for you in Fast API. Yeah, if you just pass in a callable, it will just call that for you without you having to worry about how to construct the object or this like function that you're trying to call, right?
Now, it goes deeper than that as well.
Yeah.
So, for example, in this product service here, right, he has a depends on the database connection, right? And so the first layer has a depends. The second layer also has a depends, right? And you can have however many depends down, and Fast API will just do it for you. You don't need to worry about it, okay? And it'll also deduplicate. Let's say you have not only a product service, let's say you have a product service and an order service and a user service. And one of your APIs needs all three of these services in order to do its job, right? Now that may not necessarily be good design, but just for discussion's sake, let's say that is the case. And all three of those services then again depend on a database. Well, if you were doing it yourself, you might end up duplicating the database connection, which could actually cause problems with transactions and this kind of stuff, right? But when you have something like Fast API managing dependencies for you, it creates a dependency tree and it finds where there's duplicates and it deduplicates things for you. Okay, so it's a kind of way to protect yourself from making mistakes with regards to dependencies. You can just say, I need some database connection. And Fast API will be like, I got you. It's okay.
Can you visualize the tree?
I'm sure someone has built a tool to do that, but I don't know how.
Any questions? Because I do want to keep this short. I'm not going to explain more, but if you do have questions, I'll try to answer them. Any questions? No? No questions?
So who can explain what dependency injection is? Crap. So dependency injection is the idea of you have some class or function or something, and it requires another class or function. But rather than you explicitly defining that class or function, you say, I need some kind of class or function like this. And then you let the system inject it for you. Okay? So that's why the repository, right? It's a parameter to the product service, right? And then he has a default value, but inside the function, he's not explicitly setting it, like Jason demonstrated earlier, right?
Yeah.
And that allows Fast API to say, okay, I'm going to find the right repository to use for this parameter. Now you might be thinking, why the hell would I want to do that? Why would I want to complicate this? Why not? Why wouldn't I just put the repository into the product service directly rather than have it taken in as a parameter? That's because you may want to use different repositories at different times. So for example, in your development environment, you may want your development repository. In your production environment, you may want your production repository. In your testing environment, you may not want a real repository at all. you might want to make a mock repository, like we covered in the automated testing, where you can then use that mock repository to do your testing with, right? And in this way, you allow flexibility, okay? So you can put in whatever repository makes sense for that use case, and by default, you take in the normal product repository. Does that make sense? Okay.
So you reduce dependence of concrete realization.
Yeah.
So every time you inject the class, you can create new object for this.
The depends will do it for you. Yes. You can also like put it as a default here. I'm just doing it for like demonstration purposes. But yes, like every time you create a class, you will create another class and inject it in during the creation. Yeah.
Do you like in base API, do you like make singletons for connection?
You don't need to,
Oh.
because when you do the depends, if it identifies that when building out your dependency tree, if it identifies the same dependency occurring twice, it'll just reuse it.
Oh.
So dependency injection is customizable variables to arguments with default values.
It doesn't have to be default values.
Correct.
It doesn't have, it's just like things you can put inside, right? It's just variables and like and parameters and arguments, but people made it a difficult concept, right? Yeah.
Need to like use all of like lesson function.
Yeah, we didn't cover async.
So async, I guess we can talk about async now.
Yeah.
Okay. So I'm gonna use databases as an example because we're gonna be dealing with a lot of databases as a backend, right? So so normally things run in a blocking kind of way. What blocking means is that I'm going to send a request to the database. And before and until the database responds back with an answer, I'm going to wait and do nothing. I'm going to block everything and I'm going to wait, right? This is what it means to run in a blocking way, right? But in an async kind of way, right? I can send many different requests to the database, right? I can send many different requests to a database, and I don't know when these requests, these SQL queries, will complete or end, but I can wait for them all independently of each other, and I'm not gonna stop my process or just wait for it to stop, right? And when each of these like queries that I send have completed, they will be sent back to me, right? So instead of just everything stopping and waiting for the database to complete, the async allows us to just send a whole bunch of things at once and then wait for it to just run independently, and it will just return the results to us, right? So that is sort of like an example of asynchronous like communication, right? Another example of asynchronous communication, if you're at like work and you send a message to your coworker, they don't have to read and just like respond to you directly. They will get to you when they have time, and they will respond to you when they have time. That is sort of an example of like asynchronous work, right? You don't have to like continuously just wait for the other person to respond to you. You can send off the message. You can do other stuff. And then when your coworker responds to you, you can continue the conversation or just like do your job, right? This is like an example of like something asynchronous that happens in the real world, right? And that is useful for many cases, but especially in like speeding up how things run, right? So a server can, when you get a request, you may need to do a whole bunch of queries to fulfill the responsibility of that service, right? You may need to call a payment service. You may need to call like an email, and you may need to call like the database to do stuff. And you can do all of this asynchronously. Just send it all out all at once, and then just like wait for it independently until do it instead of just for example, for like an order service, right? Someone creates a new order in e-commerce. First, you have to save the new order into a database, and then you have to send an email to the person saying your order has been received, right? If you do it synchronously, right? First, you will save to a database, right? And then you'll wait until that is done. And then second, you will send the email saying your order has been received, right? But if you do this asynchronously, right, you can send out 2 requests at once, and they will just like complete or not or whatever. And then since you don't have to wait for this to end, right, you can just respond immediately, the order has been received, right? So that is like another example of doing things asynchronously, which may speed up the response of the server. Yes, does that answer the question? Okay.
So a little add-on.
Yeah.
Remember when we talked about ASGI the other day and how the server can just kind of insert stuff where it's possible? You might be looking here down at lines 30 and 31. We're doing await, which is basically blocking for an async function to run. We're doing 2 awaits in a row. So you're like, why are we doing async? That looks synchronous, right? You're executing an async function and then you're waiting it to finish. And then you're executing another async function, and then you're waiting for it to finish. That doesn't sound like a good use of async, right? And on the surface, that makes sense. However, in reality, what's happening with each of these functions, it's making calls to the database system. When it's making calls to the database system, is that waiting on CPU, or is it waiting on something else? Yes. It's waiting on the response from the database. So that's a network call, right? And so at the lower levels of that function call, there's other async awaits going on. And so that's why we have to kind of bubble up through. And even though we're blocking this code flow to do that, while we're waiting for that to run, the ASGI server can be fulfilling a different request. Okay? So this is why, even though we're doing these asynchronous calls synchronously, right? In the background, kind of under the hood in the server, it can do this kind of like swooping back and forth. Yeah.
Yeah.
Does that make sense?
But do you have to put like limit for the like one-time like connections? Because if there is too many connections, it will just keep jumping between the actions.
Yeah. So it kind of that's basically done for you. You can get deep into things and you can configure how Python handles context switching and how many semaphores it manages and all that kind of stuff. But usually, like as a junior, that's not your problem. And even at the senior level, like you're only going to get down to that level if you're really trying to optimize stuff. Does that make sense?
You had a question?
Yeah, usually when you make an asynchronous request, you eventually get some response. So, and that may have some data that you need. So how do you receive that data that's responding from the request?
Well,
So this
Is that the meaning of await? Await is getting that data?
yeah.
Okay, so that's the meaning of await.
Yeah.
and then
So here you're saying await self-repository commit. So what data are you getting there?
Oh, this is not like getting a data. This is making sure that the changes to the database are committed. They are to make sure that the changes stay in the database, right? So I have to talk about like database transactions, which is like not related to like asynchronous stuff, but
so he's asking
Yeah.
more about like the syntax itself.
okay. Yeah.
So you'll notice here this function definition, it's async def, right? So we're telling Python this function has asynchronous stuff going on. Okay? So if you have any asynchronous stuff going on, you have to define the function as async. Otherwise the interpreter, otherwise it won't make it part of that async loop. Okay? So that's the first step. Is you have to make sure that whatever function you're operating inside has that async tag in front. Okay? And then the await says, for this asynchronous function, go ahead and block until the asynchronous function finishes. Okay?
Now, why is that important? Because if we were to get rid of this, you'll notice this changed. Now we're getting a coroutine back, right? The coroutine being an asynchronous function, right? That could still be running, okay? This might actually be a desired behavior. You might want to start running a whole bunch of asynchronous functions, get their coroutines, and then bundle the coroutines together and wait until all the coroutines finish, regardless of what order they finish in. But by doing this await, we're saying, hey, wait until this coroutine finishes and give me whatever the coroutine produces, which in this case is a row mapping.
So if I'm understanding this correctly, every statement in an async function is asynchronous unless you say await.
No,
No.
good question though. By default, everything is synchronous, okay? But the problem is, when you call an async function in a synchronous manner, calling it in a synchronous manner gives you back the coroutine, right? Because what it does is, it creates a coroutine object. Inside that coroutine object, the function is running, all right? And then that coroutine object maps to some kind of output, but that output may or may not be ready yet. And so the synchronous version of the function ends immediately and provides you the coroutine, which you can check later to see if the function is actually finished running, right? So that's kind of the synchronous version of the function. It's not a completely accurate way to describe it, but I think that's what makes the most sense, right? But when you say await can only be applied to asynchronous functions, and it says, hey, I want to wait until the coroutine resolves, and I want to get the output of that resolved coroutine. Okay? So saying await means awaits the completion of the asynchronous function. Not calling await says just run the function and give me whatever the output is. Or the output's a coroutine in the case of an asynchronous function, or if the output is data in the case of a synchronous function. That just depends. Okay, so the repository insert and the repository commit, those are asynchronous functions, but we don't want to fire and forget and then wait for them later. We just want to wait for them now. So we say await for the completion of that asynchronous function. Does that make more sense?
Yeah, so insert and commit are defined as asynchronous separately from what we're looking at.
Correct. So if we actually go look at this function, insert is an async function. Okay? And then commit is also an async function. But if we look at product create response, well, and we look at product, and it doesn't have an init method here, but the init method by default is synchronous, a normal function. If we look at, what's another one here? Where's a normal function?
There are no normal functions.
There are no normal functions.
We like async.
We do like async.
Yeah.
Well, I'm sorry, I don't have a good normal function example. But yeah, normal functions, async doesn't make sense. If you try to call async, it's going to be like, what are you doing? Normal functions, await does not make sense. If you try to use await on a normal function, it's going to be like, what are you doing? There's no coroutine here. If you do the await, it says, wait until the coroutine resolves, give me the data from that. Because what you could do is you could do something like, now this would not be good code, right? But you could do something like this, right? You can do result 1, result 2, right? And then we could say, is this JavaScript or am I? No. What's the Python to gather? Is it just gather?
Async IO.gather.
Yeah, async we could just say gather result 1, result 2, right?
Yeah. I don't think you have the awaits for the repositories, I think.
Oh, you're right.
Yeah.
So if we did this, thank you. So in this case, what we would do, if we did it this way, we would run a bunch of asynchronous functions, just collect their coroutines, and then, oh, thank you.
Yeah.
And then we would use gather to say, whenever all of these are done, let's wait until that happens. And then let's take that output and do whatever. Does that make sense?
Yeah, you can see that the type of this is coroutine, 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 and the type of this is tuple, row mapping, row mapping, row mapping. So the coroutines, they resolve into the row mappings of this. Yeah, exactly. Yeah.
So gather has a special meaning here, or is this something we write?
Gather is just a function.
It's just a function that's included in Python in the async IO package.
Yeah.
Yes.
And it's to help you manage asynchronous functions like this. Great questions, though. Does that make sense to
Yes.
everyone else?
Async is not an easy topic. Yes. And that it's okay to be a bit confused.
Right. Does that make sense to everyone else? All right. Any other questions regarding dependency injection or async or whatever?
Done? We're good?
Awesome. So thank you, Jason. So the official day is over. Okay.